Okay, in this video we're going to look at number 43 in section 5.3, and it asks us to rewrite in the form y equals a sine bx plus c this sinusoid. So we did this in section 4.7, but we used our calculator, and today we're going to learn how to do this without our calculator. So remember, anytime the omega is the same, that means that this can be written as one sinusoid. So that's all we're really doing. And in this case, we know that b and omega mean the same thing. And in our problem here, omega is equal to 1. So I'm just going to rewrite what they're asking us to do. They're asking us to do a times the sine of 1x plus c. We want this sinusoid to be rewritten as one sine function. Now, sine of x plus c, well, that's a u plus v situation. So I'm going to rewrite the right-hand side of this, and we're just basically going to walk through all the steps on how to do one of these, and then hopefully practice one together when we're back together. So we have sine of u cosine of v, if I'm expanding that x plus c out, plus cosine of u, which is the x, right, because this is u plus v, sine of c. And then I'm going to distribute the a in. And you'll see why we're going to do this in a sec. Now, remember, we're looking for a and c in this formula. Those are numbers. And so this is a number. So I'm going to take the cosine of c and put it in front of the sine of x on both of these. So I'm going to say cosine of c times the sine of x plus a sine of c times the cosine of x. And we're supposed to rewrite this one that we were given. We're supposed to find a and c, because if I find a and c, I can plug them into this formula and we'll be done. All right, so it's not super intuitive from here. I'm going to write this 3 sine x plus 4 cosine x below so you can see what's happening. 3 sine x plus 4 cosine x. We're just going to write it below the blue one. And if we look at this, what's happening here is the sine of x is there. And so that means that the 3 has to equal a cosine c. So I'll write that over here. A cosine c has to equal 3, because a cosine c times the sine of x is supposed to be 3 sine x. And a sine c is going to have to equal the 4, because the cosine of x is the same there. So we're going to say that a sine c is equal to 4. Now, this next step, you would not know to do this unless, when you read the book, you saw it. When you watched Mr. Taru's videos, you saw it. But what we're going to do is we're going to take these and we're going to try to solve for a and c. We have 2 equations, 2 unknowns. Anytime you have 2 equations and 2 unknowns, you can solve. So we're going to take we're going to square both of these equations. And I'm going to write them one on top of the other. So if I square the first one, I get a squared cosine squared c is equal to 9. If I square the second one, I get a squared sine squared c is equal to 16. Okay, so that's the next step, right? And then the next one we're going to do is we're going to add these 2 equations. So if I add these 2 equations, I get a squared cosine squared c plus a squared sine squared c is equal to 9 plus 16. There's an a squared in both of these, and I see a Pythagorean identity inside here. Oh, that should have been a 16, equals 25. So I factored out the a squared, and now this is a Pythagorean identity equal to 1. So I have a squared is equal to 25. So a is equal to the square root of 25, which could be plus or minus 5, and I'm going to pick the plus 5. Okay, so great, I know a. So all I need now is to get c. All right, how do I get c? Well, the next step, we're just going to plug a back into one of our equations. It doesn't matter which of these 2 equations I plug into. I have these 2 equations up there. So I'm going to plug a in, a equals 5, into the first equation. So we have 5 times the cosine of c is equal to 3. Right, plugging into this equation here. And so the cosine of c is equal to, divide both sides by 5, 3/5. And if I want c, that means I have to cosine inverse both sides, which we've done in the past. So we're going to cosine inverse both sides. And we get c is equal to the cosine inverse of 3/5. This is a number. We don't need to go any further than that. That itself is an acceptable number. And so I know what A is, and I know what C is, and now I can plug into my equation. I know B is 1, because from my original problem, the omega was 1, that's B. And so we can rewrite this answer as A is 5 sine of x plus cosine inverse of 3/5. You just plug that messy C right into your formula. And that's how you find the equation of a sinusoid when you're combining two that have the same omega.